Let's find the work done in emptying a conical tank. We will use as our acronym for work the integral of ADD volume, and the key to this formula is knowing what each of the letters stands for. We will be emptying a tank between 0 and 8. A stands for acceleration due to gravity, and the first D stands for the density of the fluid, which is 1,000 for water, kilograms per meter cubed. And then if we look at our tank and we look at a cross section right here, the second D is representing the distance that cross section has to travel, and that is going to be 8 minus y. This is the general cross section at a height of y. So it's going to travel 8 minus y to get out the top of the tank. And then volume is not the volume of the tank, it is the volume of this slice right here. So this slice is going to have a thickness of dy. So the cross section is two-dimensional, the volume is three-dimensional. That's a slice. That's what we mean when we say slice. We add some thickness to our cross section. Okay, well, in order to figure that out, we are going to notice that if we look at different slices, they are going to have different radii. And so what we're going to need to do is figure out the area of a cross section based on the y value. So we are going to want to find the equation of this line right here. Well, this point down here is the origin, and we can imagine this point up here being 1, 8. And so the equation of that line is going to be y equals, we go up 8 over 1, so the slope is 8, so that's 8x. We are trying to measure a radius, and a radius is horizontal here. So we want the distance horizontally, which means we are looking for x values. So if we solve this equation for x, that is going to correspond to the radius of the corresponding cross section. All right, so the area of our disk will equal pi times the radius squared, and the radius in this case is y divided by 8. And so we can say that the area of this disk is going to be pi times y squared over 64. So that's the area of the cross section. Now we want volume of the slice, so we're going to take this cross-sectional area, and if we multiply it by dy, we now have volume. So this is volume. Now we just have to do the math here. So we are going to pull the 9800 out to the front. We'll pull the pi out to the front. We'll pull the 64 out. So let's see, we're going to have 9800 in the numerator, a pi in the numerator. Denominator, we have a 64. And we have the integral from 0 to 8. And let's see, let's distribute that y squared. So we'll have 8 times y squared minus y cubed times dy. So there's where we're at right now. Let's go ahead and do the integration. I'll deal with these constants out in front in one moment. Let's focus on the integral. So we will have 8/3 times y cubed minus 1/4 times y to the 4th, and this will go from 0 to 8. All right, so let's go ahead and start plugging and chugging here. So let's simplify this coefficient out in front. 9800 over 64, let's divide them both by 8. That will give us 1225 pi divided by 8. We're going to plug in an 8 into the antiderivative right here. So there's, whoops, let's see. There is our antiderivative, so we're plugging in 8. That's going to actually give us 8 to the 4th over 3 minus 8 to the 4th over 4. So we can factor out that 8 to the 4th, leaving 1/3 minus 1/4. We then can cancel out one of those 8s, giving 8 to the 3rd, and get a common denominator of 12 here. We'll have 4 minus 3 over 12. Okay, we're getting there. So 1,225 pi multiplied by 8 cubed. 8 cubed is 512 multiplied by 1/12. And this will simplify to 156,800 pi divided by 3. And units of work, Newton meters, or we can use joules.